This question is from GATE 2014, Mechanical Engineering Paper Set 3, question number 39. Consider an objective function z of x1, x2 is equal to 3x1 plus 9x2 and the constraints x1 plus x2 less than or equal to 8, x1 plus 2x2 less than or equal to 4, x1 greater than or equal to 0, also x2 should be greater than or equal to 0. The maximum value of the objective function is dash. So we need to maximize the function z. Let's see how z can be maximized subjected to these three conditions. So we can plot the two variables x1 and x2 on this axis, O being the origin, 0, 0. First constraint says x1 plus x2 should be less than or equal to 8. So to plot this, we'll convert this to an equality. X1 plus x2 is equal to 8. Putting x2 as 0, we get x1 to be 8. x1 as 0, we get x2 to be 8. So on both the axes, we can plot 0, 8 somewhere here and 8, 0 somewhere here. This is the line that represents x1 plus x2 equal to 8, and this is the region that represents x1 plus x2 should be less than or equal to 8. The second constraint is x1 plus 2x2 is less than or equal to 4. Again, converting this inequality to equality in order to plot it, x1 plus 2x2 is equal to 4. Putting x1 as 0, we get x2 is 2. So this becomes 0, 2 somewhere here. And putting x2 as 0, we get x1 as 4. So this belongs somewhere here. That is 4, 0. So the line that represents this x1 plus 2x2 equal to 4 will be this line. And the region that will represent the inequality is this region. Now, this region cannot be expanded in the negative x1 and negative x2 axis. That is because we have two more constraints. x1 should be greater than or equal to 0 as well as x2 should be greater than or equal to 0. So the area that we are being bound to is the positive x1 bounded with x1 plus x2 less than or equal to 8. Also, the area that we are bound to is between the green line and the axis as well as yellow line and the axis. The overlapping area here is this area. So we need to check the value of function z on the three end points of this area, the three limiting points of this area. We need to check z at 0, 0, z at 4, 0 and z at 0, 2. So z at 0, 0 will be, z function is given as 3x1 plus 9x2. So we'll put 3 into 0 plus 9 into 0. This is clearly 0. Z at 4, 0 will be 3 into 4 plus 9 into 0, which is 12. And z at 0, 2 will be 3 into 0 plus 9 into 2, which is 18. We are being asked to maximize z, not minimize but maximize z. So definitely z has a maximum value of 18 at 0, 2. Let's go back and fill in the answer. Maximum value of the objective function z is 18. This problem belongs to the topic linear programming. To learn more about this topic, you can refer to the NPTEL video, Lecture 3, Linear Programming Solutions, Graphical Methods, from the course of lecture series on Fundamentals of Operation Research. This course is by Professor G. Srinivasan. He is from Department of Management Studies, IIT Madras. I hope this solution will help you clear your doubt. Thank you.